everyone, and welcome to the Mat 211 review on partial derivatives. My name is Julia, and I work for the tutoring centers at ASU. So for today's problem, we're going to look at this function, f of x equals 9x cubed times y squared, and we're going to determine the following four second-order partial derivatives: f of xx, f of yy, f of xy, and f of yx. And then we're going to evaluate all of these at the point 1, 1. So first things first, let's talk a little bit about the notation here. So when we write a derivative such as f of xy, we read this is a second order partial derivative, and we read this in this form left to right. So what this means is that we're going to take the derivative of f with respect to x first, and then we're going to take that resulting derivative and we're going to take the derivative of it with respect to y. So another way to think of this is that we're taking the partial derivative with respect to y of the partial derivative of f with respect to x. So in either case here, we're going to start with a partial derivative with respect to x or a partial derivative with respect to y. So let's go ahead and find f of x and f of y first, just so that we can get that out of the way. So f of x is going to be the partial with respect to x of our function 9x cubed y squared. And if we look at this, we just have one term here, which has x. And remember, our y term here is just going to come along as a constant. So this will give us 9 times the derivative of x cubed, which is 3x squared, times y squared. Or, if we want to make this look nicer, it's going to be 27x squared, y squared. Similarly, our partial with respect to y of f is going to be, let me just write this out here for us first. It's going to be, in this case, our x is going to be a constant. Our x cubed is going to be a kind of a constant-ish term. So we'll say 9x cubed times the derivative of y squared, which is 2y, or 18x cubed times y. So let's go ahead and write these up in the corner just so we know what they are. We keep them in our memory. So we have f of x equals 27x squared y squared, and f of y equals 18x cubed y. Great. Now let's move on to our second order derivatives here. First, we'll clean up some space. All right, let's start with f of xx. So we know that we're going to start with the derivative of f of x, and we're going to take that the derivative of that with respect to x again, or the partial derivative to be more explicit. So f of xx is going to equal the partial with respect to x of f of x, and so we can write in our 27x squared y squared, because that's our f of x here. So then again, we're just treating y as a constant for right now. So this gives us 27 times the derivative of x squared, which is 2x, times y squared. And if we clean the math up on this, we have 54x y squared. So that's our first derivative. So let's write it up here just to get it out of our way. Our second order partial derivative, that is. xy squared. Whoop, that is a squared, not whatever that was. There we go. All right, we'll clean up here. And next we're going to look at the partial with respect to y. So we'll just clean all of this up again. Or the second order partial with respect to y. So f of y is the partial with respect to y of f of y, because again, we start here and then we take another one here. And so that'll give us, we're going to use our 18 x cubed y here. And our x cubed here is going to be treated as a constant for this partial derivative. So we'll have 18 x cubed times the partial of y, or partial derivative with respect to y of y, which is just 1. So we have 18 x cubed for f of y. Let's write that up here again. 18 x cubed. Great. So now that we have those two out of the way, let's look at f of xy. So in this case, we're going to start with the partial with respect to x, and we're going to take the second partial with respect to y. So we'll have partial with respect to y of partial of f with respect to x, and we can write that out explicitly. So we're going to grab our 27 x squared y squared here. And so remember, we're going to treat x squared as a constant. So we have 27 x squared times the derivative with respect to y, partial derivative with respect to y of y squared, which is just 2y. So that gives us 54 x squared y. So we'll write that up here, 54 x squared y. And lastly, we're going to take the partial f of yx. So again, remembering what our notation means here, f of yx, that's going to be the partial with respect to y of our f of y, or excuse me, the partial with respect to x, of our partial with respect to y, which is 18 x cubed y. And so that'll give us 18. And then the derivative of x cubed here, which is times 3x squared, times y, which is just a constant. And if we multiply this out and gather our terms, this gives us 54 x squared y. 54 x squared y. Note that these two are the same. That is often going to be the case. Not always, but in situations where your function f of x is continuous and the second order partial derivatives are continuous over the same domain, then you will have that your derivatives will be the same as well, or your partial derivatives, second order partial derivatives. All right, so last thing, we've got everything good here so far. So last thing we need to do is evaluate all of these at 1, 1. Well, that just means plugging in 1 and 1 into all of our values here. And this should be pretty straightforward. So we've got 54. Well, actually, let's write this down here just to make sure that it's clear. So we've got f of x at 1, 1 is going to be 54 times 1 for our x times 1 squared for our y. So that's just 54. And f of y at 1, 1 would be 18. And notice this one doesn't have a y term. That's okay. So we'll just substitute the value for x in here. And what that just means is that this second order partial derivative yy with respect to yy is going to be constant at all values of y. So it'll only vary with values of x. So that'll give us 1 cubed here. And of course, that's just 18. Same process goes for f of xy and f of yx. And they equal the same. So we know that evaluated at 1, they'll equal the same. So we can say f of xy equals, at 1, 1, of course, at 1, 1, equals f of yx at 1, 1 equals 54 times 1 squared times 1 equals 54. Boom, we're done. So that's it. So before I go, I just want to remind you all that if you are looking for additional tutoring or academic support services at ASU, please visit the Tutoring Center website, tutoring.asu.edu. You can also use the tutor search function, which you can find right on this main page, or by going to this full link. The tutor search function allows you to find tutoring services for a specific course. So thank you so much and have a great rest of your day.